4.6 is called arithmetic sequences. So an arithmetic sequence is an ordered list of numbers, like these, in which you add or subtract the same thing to get from term to term, okay? And the number that you add or subtract to get from term to term is called the common difference. Should have made a bigger space here, but okay, got it in there. It's called the common difference, okay? And you can find this number by taking any term and subtracting the previous term, okay? So in these examples, we're going to find the next three terms of these arithmetic sequences. So we're told that these are arithmetic sequences. That means we should be able to add the same thing or subtract the same thing to get from term to term, okay? So this one, you can probably see the pattern pretty easily. We're adding 3. 2 plus 3 is 5, and then 5 plus 3 is 8, and 8 plus 3 is 11. And we can just keep adding 3 to generate more terms, right? So if I add another 3, 11 plus 3 is 14, and 14 plus 3 would be 17, and 17 plus 3 is going to be 20. So my next three terms then would be 14, 17, and 20. So my common difference is 3. I get the same difference out every time, okay? And you might notice you can also take any term and subtract the previous term. If I did 8 minus 5, that would give me 3. So that technique's going to be useful if you have large numbers or fractions or decimals or something like that, okay? On the next example here, we're actually subtracting, right? And subtracting is, you can think of it as adding a negative. So you can think of, well, what do you have to add? Here you'd have to add something negative. I kind of just think of it as subtraction. So I'm thinking, okay, 27 minus what would give me 19? That would be negative 8. And just to show you, you could take any term, like the 19, and subtract the previous term, and that would give you your common difference as well. It'll work with all of those. Take any term and subtract the previous term, okay? And then we're going to keep getting negative 8, so I'm just going to subtract 8 3 more times to get the next three terms. So 3 minus 8 would be negative 5, and then negative 5 minus 8 would be negative 13, and negative 13 minus 8 would be negative 21. So there's my next three terms there, okay? All right, so here we're going to be adding something again because these numbers are getting bigger. And again, you can eyeball it. You can just think 0.2 plus something equals 0.6, or you could take any term. You don't want to use the first term, but take any term other than the first term and subtract the previous term, and that gives you 0.4. So we're going to be adding 0.4 here from term to term. Common difference is 0.4. So when I add another 0.4, that'll give me 1.8. Plus 0.4, that's going to give me 2.2. Add 0.4 one more time, that gives me 2.6. There's my next three terms. Okay? All right. To graph an arithmetic sequence, we're going to use ordered pairs. Okay? So you might notice here, hey, we've got an XY graph. And with this sequence, these aren't XY pairs. But we can make them into XY pairs by using the term numbers, okay? So by that, I mean, hey, my first number in the sequence is the 3, the second number is the 2, the third number is 9, and the fourth number is 12. Okay, so I wrote that pretty small there, but those are my first four terms, so I just put those are my term numbers, 1, 2, 3, and 4, okay? So I'm just going to think, okay, well, my first term is 3, my second term is 6, third term is 9, fourth term is 12, and then I can use these as ordered pairs. And I could generate more terms if I needed to, but I'm just going to graph those four. Okay, so let's plot them. I've got 1, 3, I've got 2, 6, 3, 9, and 4, 12. Okay, now it's tempting to connect the dots and draw a line that connects those, but we're just plotting the points themselves. We're not going to connect them with a line, okay? But you might notice a pattern there, and those do all line up in a straight line, okay? So when it says, what do you notice? They're lined up in a straight line. So I'll say they are, lined up along a straight line. Okay, and that is always going to happen with an arithmetic sequence. Okay, so the graph of the points from arithmetic sequences is arranged in a linear fashion, means in a straight line. Okay, that always happens. So that's nice to know, because you'll have some problems where they'll show you the graph and they'll say, well, would this be an arithmetic sequence? And all you're looking for is if those points are going to be in a straight line or not. Okay, so that's exactly what's happening on this next page. We've got these two graphs, and do they represent arithmetic sequences? Well, this one does appear to, because it looks like it's in a straight line. This one does not, because it has a curve, right? So we want to have a straight line, not a curve. Okay. All right. So let's look at this next example down here. I'm going to skip this for just a second. So this is a sequence. This is sequence A, and often we'll see this written with a little footnote thing. And so when this says find A sub 71, that means we're going to find the 71st term in sequence A. Okay, that's what those directions mean. So I could start building it. I can see, okay, I'm going to be subtracting 6 to get from term to term, and I could build this sequence out until I have 71 terms and then find out what the 71st term would be. That's going to be pretty tedious and take a while. So we have an arithmetic sequence equation that's going to help us to solve problems like this much quicker. So here's how it's going to work. We've got this equation. It's going to look like this. Okay, so A sub 1, this means this is the first term in the sequence. Okay, the D is going to be the common difference. So that's whatever you're adding or subtracting to get from term to term. Okay, and then the N, the last piece here, the N is going to be the term number. Okay, and this is going to make it much quicker to find a specific term that's far down the line. If I was just looking for the 5th or the 6th term, I'd just build it out. But the 71st term, I don't have that kind of time. So let's use this formula. Let's start plugging stuff in here. We're looking for A sub 71. Okay, so the first term is 20. The difference, that's what I'm adding to get from term to term, and I'm adding -6 or subtracting 6. Okay, so I'm going to put a -6 in like that. Okay, and then for N, my N here is 71. That's my term number. That's the one I'm looking for, so I'm plugging in a 71 right there. Okay. And now I'm just going to solve this using PEMDAS. So I got to think, what do I do first? I'm going to work inside parentheses. There's only one thing to do inside the parentheses. That's that subtraction there. Okay, and then I've got multiplication and addition left. I'm going to do the multiplication next. Here I'm going to have to work to the right from here. So this is going to be 20 minus 420. Okay, and then when you, that's going to give me -400. Okay, so if I did build this out to the 71st term, that 71st term would be -400. Kind of makes sense. We'd be pretty far into the negatives. The very next term would be a negative term, and we'd be pretty far down the line in the negatives by the time we got there. Okay. All right, so let's try another. Using that same formula again, we're going to find A sub 38. We're going to find the 38th term here. So we're going to need to know what the difference is, okay? And looking at these, I think the 2 and the 8 are the easiest to use. 2 plus something equals 8. Well, that would be 6. and then I just make sure it works with the rest of these, and it does. So my common difference is going to be 6. Okay, so let's see. Here, I'll just write the formula here, just to have something to plug things into. So I'm looking for the 38th term, right? The first term is going to be -10. My difference is going to be 6. And then n for this is going to be 38. Okay? And I'm going to do the subtraction inside the parentheses first. Then I'll do the multiplication. So here, just to make this quick, I'll use my calculator. 6 times 37 is 222. And then 222 minus 10 is going to be 212. Okay, and that would be the 38th term then in that sequence. So I was off screen there a little. Okay, so let's try one more. Oh, this one's a little different. This is not asking me to find a specific term in this sequence. When it says write an equation for the nth term, that means I want to write an equation something like this. So I'm using the same formula. I'm going to use this formula and I'll plug everything I can into that. I'm not looking for, you know, the 71st or the 38th term. I'm just writing an equation so that I could build any term. Okay. So the things that I'm going to plug in are these two pieces, and that's it. Okay. Those are the only pieces I'm plugging in. So my first term is 3, and then my difference, I can see I'm adding 5 to get from term to term. Okay, and you could actually call it a day here, but we can simplify this a little bit. So I can write this, if we write it without parentheses, it's considered simpler, and I can distribute then. Okay, 5 times n is 5n, 5 times -1 is -5, and I can simplify a little further because I've got these like terms now that I can combine. Okay, so 3 minus 5 would be -2. And now I've got this equation written for the nth term. So now I could use this very easily. If I wanted the 100th term, I just plug in 100 for n. If I wanted the 200th term, I plug in 200 for n, and so forth. Okay. That's also called writing a rule. You might see the directions written like that sometimes. Okay. All right, that's the end of the lesson, and I'll see you next time.